Supplemental math videos from Circle Christian School. XYZ systems. These can be important when you're actually have three variables going on. Like in a case of where maybe you have French fries, a drink, and a hot dog, and you have to find out some specifics about them. There are other things that happen geometrically with these, but that's the reason why we have XYZ systems. There are three variables, and it works a lot into our three-dimensional world. All right, we're going to start out with the basic here, that we have three linear type equations, has an XYZ of three variables. This is the most basic, where you're going to end up back substituting to go find your equations. So I'm going to start at the very beginning, and that is that we know z equals 3. Always a good place to begin is right at the beginning. That was supposed to be yellow. It's not, but okay, maybe we can make it yellow just because it's more fun that way. So we know z equals the 3. So now we're going to plug it back in to go find what y is. So we have y plus 2, and my suggestion here is that anytime you take a letter away, make sure you always use some sort of parentheses to put it inside. Replacement, substitution. And we know that a positive 2 times 3 is a 6, so we can kind of quick step this and go minus 6, minus 6. And y is going to equal a negative 1. So now we have what y is. And we're going to back substitute that into, you can do either one. No, you can't, because we're looking for x. Silly me. I have to back substitute into the very first one at this point, because we have to go find x. So now I'm going to go find x minus the 2. I'm going to take away the y plus the 2z. And you know me, I like to make a template as we work along here. So I'm going to put in my z, which I know is 3, my y, which I know is negative 1, and I'm going to go solve for x. So we have x plus the 2 plus the 6 equals the 9. So we can go minus 8 here, minus 8. That is a bit of a quick step, but you're to that point now. And x is going to equal 1. And the deal here is that our solution set for the three equations is that x is 1, y is negative 1, and z is 3. And we should be able to replace it to any of the equations here and have a true equation. So if we put it back into the first one, which we have a 1 minus the 2 times a negative 1 plus a 2 and the z, which is a 3, it should equal the 9. And so we have 1 plus the 2 plus the 6, and yes, it does equal 9. That one checks. We should be able to put it into the next one, that we have y is a negative 1 plus a 2, taking the z away, which is a 3. And it should equal a 5. A little bit of George Polya here. So we have 6 take away 1, so 5 does equal the 5. That's awesome, good. And of course we already know what z is. That's the 3. Okay, let's try this again for the third time. First time my neighbor called and I thought I paused it. It didn't. Second time, I have no idea what happened because the computer went crazy wazy. So you can put that in your notes if you want. Okay, so let's try a little more intense one here, where we have to deal with x, y, and z, and nothing's really pretty. but the whole deal is to make two new YZers. That's what I call them. That's a Z there. Not a very good one, but it is. And so checking this, as I've got this X here that doesn't have a coefficient to it, it just seems like a nice one to go play with. So we're going to work between these two right here. And I'm going to multiply to my top one a -3, because what I want to do is get rid of the X's. So we're going to do the rewrite. Remember not to mess with the originals, and just write down below. So I have a -3x, watch the integers, +3y, -6z. We're just distributing out as we go. And then we get a 3x plus the y. We're just rewriting this as it is. We didn't have to do -6. Now we're going to combine them. That means we're going to add them together. And the whole deal is to eliminate the x's there. Gives us a 4y minus the 10z equals 6. And I'm going to put a little box around this because I'm going to need him in just a minute. All right, next I'm going to check out the 2x here and the x. So those are the ones that I'm doing now. So I'm going to multiply to the top here a -2, making those equivalent equations. So I get a -2x, a +2y. Remember, you can stop this at any time and just slow it down and take a look at it. Equals, let's see, a +8. Rewriting the bottom one here. Don't have to do anything to it. And again, we're going to combine them together. Whole thing is to get rid of the x's. So I say goodbye. Adding the y's and the z's. So I get a 5y minus the 8z equals a 12. Putting a box around it because I'm going to need it. All right. Now the whole thing here is that I need these two variable equations so that I can end up isolating the z. So I take a look at the 4y and the 5y. That's what I want to eliminate now. And the thing that's common between 4y and 5y is a 20y. What I need here is a +20y and then a -20y, which means I'm going to have to multiply a 5 to the first one and a -4 to the next one. Distribute it out. 4 times 5y is that 20y. 5 times the 10z is the -50z equals 30. And now I'm going to multiply the 4 to everybody here. And that gives me the -20y, a +32z. This is where you get to really practice a lot of multiplication and integer type of things. When your mom said, hey, you have to learn your multiplication tables, this would be one of those reasons why. Now we're going to combine them. The whole thing is to get rid of the y's. And that's what they do. They say goodbye. And we get a negative 18z equals a -18. And quick minds will be able to figure out that z equals a 1. Or you could do it over here, z equals 1. And you take a look at your solution set that I should have written over here before I started, which was -2, 4, and 1. Before I started, make sure you just take a look at the answer, write it over here, because you can take a look and go, hey, yay! I got a 1, and that's one that they have right there. So now I'm going to take this z equals 1 and put it back into either 1 of the y zeros here. I don't care which one you pick. It's up to you. So I'm going to put it right here. So we have 4y times the 1 equals 6. You can quick step this and add a 10 and add a 10. 4y equals 16. So you know that y ends up equaling 4. Awesome, cool. And you take a look back at the beginning and go, okay, z equals 1, y equals 4. Doing really good so far. Pick which one you want to put it into. The top one looks like the best one to go find x minus 4. Sorry, let me wipe that out. That I take the y away, use those parentheses, and it's a 4, plus 2 in the parentheses, and the z is the 1, equals the negative 4. And so we have x negative 4 plus the 2. Do a little bit of mental math. Try to avoid the calculator. Mental math. Calculator's just a checker at this. So it should give us a negative 2 equals the negative 4. So I'm going to add 2, of course, to both sides. And x equals negative 2. And again, I go, yay. That's what we have here for the solution set. And if you put it back into any of these equations, it should make a true statement.